Hey guys, welcome to System Design Fight Club. We do these live every Saturday evening at 6 p.m. and 10:30 p.m. Pacific Standard Time. Tonight, we're going to be covering the ad-click aggregator problem, which you can find in Alex Shu's second book. There's a lot of similar problems to this that I've seen. I think the metrics aggregator, which is a really popular design as well, has a lot of overlap with this. Yeah, so with that, we'll get started. Okay, so I'm going to use, I liked the numbers that Alex Shu had for this problem. So it's the ad click aggregator. We're going to need to cover functional requirements. We're going to need to cover, okay, good, I'm not muted. Non-functional requirements. Then we're going to do numbers, the back of the envelope estimates. Okay, so we're going to want to have, we should record ad click events. We don't handle any of the logic for placing the ads. We're mainly going to focus on capturing the, I like the word capture a little bit more. Or we should capture the ad click events. We should be able to query the ad click events as a marketing analyst. So this is that's going to look a little bit like Google Analytics if you've ever used it. I imagine Facebook has something similar to it. Numbers. All right, so this is something that I haven't done in the previous time I tried to cover ad click analytics. I really liked Alex Shu's number. We're just going to go ahead and copy them. We're going to have 1 billion clicks per day, 2 million ads, 2 million unique ads. You can have up to a few minutes of latency from end to end. Actual ad clicks should be pretty fast. That's a non-functional requirements. Correct, should be pretty fast. So that's fast as in low latency. To a few minutes end to end. We can say peak is 5x the normal volume. We'll get to that in the numbers section. I want, 0.1 kilobytes per click. And that's mostly analytical metadata like their gender, age, hobbies, all that creepy stuff. Cool. All right. With that, I usually like to start with the numbers now, not just dive straight into the diagram. So I want to have how many clicks per second. I'm interested in the analyst volume 2. I didn't actually have any numbers for that. We could say that we have 100,000 monthly active users for analysts. And we're going to say that they click it once every, they do, I want to have like at least a decent TPS for the analysts. We'll say they look at it about 10 times per day. On average. Okay. How many clicks per second? How many analytical page views per second? How much bandwidth for the clicks? And how much storage for the clicks? So like how many DB nodes are we going to need? And I want, we're gonna say that we're gonna store we'll start with 1 year of data. I think it'd be fair to hold on to it for 10 years, actually. So we're also gonna do how much storage for 10 years of data. And that'll help us determine how many DB nodes we need in some cases. Okay, how many clicks per second? Well, we have 1 billion clicks per day. We have 100,000 seconds in a day. So that takes us to you multiply it by 10 once to get 1 million. So that's 1,000 times 10. So that is 10,000 clicks per second. We'll say peak is 5x of the bottom of average. So up to 50,000 TPS. That's going to be interesting for the bandwidth. Okay, so we're going to say we have 10,000 TPS average. The peak is going to be we're going to need to be scaled up enough for the peak though too. So there's that, and then it's 0.1 kilobytes per click. So we're going to want that, and then the peak is going to be that with 50,000. Okay, so we're going to do this one first, and then I guess we can just multiply it by 5. So this comes out to 1,000 kilobytes per second, which equals 1 megabyte per second. That's really not that bad at all. I'm wondering if I did the math right, actually. I think it's probably going to be core bound. So each request actually, unless you're doing continuation passing style, each request is going to occupy a core of your CPU. So I think in reality, this is probably going to end up being core bound, like CPU bound by the number of cores, since each request has to occupy a core. Okay, but at peak, we're going to have 5x of that. So that's going to come out to 5 megabytes per second. And again, it's like you can very easily get a 1 gigabit internet connection. That's trivial. You can definitely get that for a super expensive service. I'm really curious if I actually did this right. Maybe it's more realistic to have 1 kilobyte per click or something, but that's just that's not going to be our constraint here. I think we're not really going to be bandwidth bound based off those numbers. Okay, so how much storage for 1 year? So we have, on average, we're going to go off the average for that. We don't have to worry about the peak when we're talking about long-term storage. So it is going to be 1 megabyte per second times 100K seconds in a day times 365 days in a year. So we have 1 megabyte times 100,000 times, we're going to round it down to 333, which is an easier number usually. So we have 100K megabytes times 333. I guess we don't actually even need, we literally don't need to do any rounding. We can just stick with 365 because these numbers are just so clean. So 100,000 megabytes times 365, so it's 365 2 zeros K megabytes per year. So we add a comma there, and then that equals 36.5. So it was already K. We already had the K on. Okay, so let's just focus on that K first. So we're gonna remove that, and we got gigabytes, and then we're gonna switch it down by another factor of 1,000, and then we go to terabytes. So it is 36.5 terabytes per year. So that's a fair amount. That requires that's probably going to require a good couple of hard disks. Not like a whole fleet of them or anything, but that's probably going to take a couple of hard disks. And then for 10 years, we're going to have, that would be 365 terabytes, because it's 36.5 times 10. Yeah, so how many analytical page views per second? So we said that we have, I didn't get any numbers for this off of Alex Shu's book, by the way. I was a little disappointed by that, but it's very obvious that the analysts are going to be a way smaller amount of traffic. And so we're probably going to be able to get away with 1 or 2 hosts or something on that. But I would have liked some numbers. I would have liked some numbers there. So I'm just making my own. Okay, so we have 100,000 monthly active users for analysts. So we're going to say 100K. I've seen some people sometimes will do this thing where they like half it for the number of daily active users or something like that. We're going to stick with there's just 100,000 analysts, and we don't really have much of a drop in retention or anything like that. It's 100,000 daily active users. And they are viewing it 10 times per day on average. So 100,000 times 10 to get the number of page views per day. So that would be 1 million. So 1 million page views per day. So then we're going to do 1 million divided by 100,000 seconds in a day. So that equals 10. So that's our TPS. So 10 TPS for analyst page views. Yeah, so it's a lot lower. We have 10,000 for the, it's 10 views per second for the analysts. And then for the ad clicks, it's up to 50,000 with an average of 10,000. So it's a factor of 1,000. It's probably going to be even lower than that. I probably had it way above what the realistic numbers would actually be for the analysts. I don't know where I posted that. Oh, well, whatever. Oh, here it is. Yeah, this is probably way more big numbers than is realistic, but whatever. Okay, with that, we can go ahead and jump into the diagram. So I always like to start with the endpoints. So we're going to have the browser for the clicker. And we're going to have the browser for the analyst. Okay, do I have, sweet, I got some stuff I can use for DVs in there. Okay, so we have the clicker. I want to make sure we have enough space. Okay, so we have that clicker. So we're going to have, we're not going to focus on this aspect, but we're going to have this like ad placement aspect. So we're going to have this ad placement service. Oh, okay. And so when you're loading up the page, there's going to be these static assets. Do I have a CD? Yes. Okay, so this is going to be our CDN. Okay. We have our CDN for the static assets. That's like the JavaScript and the HTML. And so first, you're actually going to load up your static assets. So that's the HTML page. And then you are going to have you might even do server-side rendering in some cases. I don't know if the ads are fetched off of, it depends on, you're going to call the ad placement service depending on, it'll be the client side if you do static assets, possibly, but then if you do server-side rendering, you have a server-side rendered page, you'd actually call the ad placement service directly on a back end. But you're going to call this is one important aspect I want for deduping the ad clicks. That's something that's important. This will have a UUID for the ad. It's going to return a UUID for the ad, and it's also going to return the ad ID for what we want to render. And then given the ad ID, it might make a call to the CDN again for the actual image of the ad that they might possibly click on. And then here's the important part. Here's what we want to focus on is we now want the ad capture, ad click. It's the click capture service. And this is where we're going to start the focus of today. So you return an ad, you get it loaded into the browser, and then you click on it. And then when you click on it, you're going to call this service, and then it is going to return 304 redirection after it properly captures it downstream. But you're going to do 304 or 30x redirect event. I think there's a couple of different ways you can do a redirect. One of them's temporary, one of them's permanent. I think it's 302 and 304. So 304 is an example of one of the redirects that you can do. So you have the request come in, and you're going to want to capture it. So there's going to be a lot of stuff going on. You're going to eventually get it into a database. Which one of these looked better? I think they look about the same. We're going to use that one. Okay, so you're going to want to eventually capture it in a database, but you know, it depending on your choice, you might have you really want to have high availability of this database. Oh shoot, I didn't deep dive that in FRs. I just talked about that. Okay, well, so we're going to want high availability for the add click events. Eventual consistency is good enough. I think I mentioned that you can have up to a few minutes end to end for the each click event to start showing up to the analyst over here. So eventual consistency is good enough, but we're charging for each ad click. So mesothelioma ads on Google search results, by the way, are about $1,000 a click. So that's kind of like that's kind of an important number. Mesothelioma ads charge $1,000 per click. I kid you not, I've seen that. So we don't really want to double charge. We don't really want to have any double charges occur. So revenue is important. And we also don't want to have any dropped clicks. So if we have any outage at all in our database, that will result in some dropped revenue. So you're going to want to have high availability on wherever you're going to store these ads. So you're actually going to want to use a message broker. Actually, I think I had a nicer shape for that. Can I stretch this? No, I can't. Okay, we're going to stick with this for our tube. So this is going to have a high volume, 10,000 TPS minimum. We're going to go with Kafka. Kinesis also works for a broker. You don't really want to go for RabbitMQ or SQS. Those are message queues. I think you can get them durable as well, but the big issues with back pressure is that if there's any outage over here and you start to get back pressure on your message queue, it could result in some dropped operations. It's kind of like load shedding, I think, with a regular old message queue. And so when you have such high volume, it's better to go with a stream in general. So we're going to use Kafka over here. So the click comes in, you're going to capture it on your stream, and then the stream is going to be like, yep, got it. And then you send back the 304 redirect or something like that. Okay. So the click comes in, we're going to want to capture some data. Let's talk about the request and response contract. So the request is going to have the ad ID. We're going to have user metadata, and that's going to get us to our 0.1 kilobytes per click. Since the ad ID, what else do we want to know about the user? Oh, timestamp. We want to know the timestamp for the click event for when we're aggregating it. I think that's, yeah, I don't really want to go into the metadata a whole lot, but that's going to be the general gist of our request. And then for the response, it's a 30x redirect event. Yeah. Okay. So we capture it there, and we're going to want to, depending on if it's, so I'm going to go into both aspects. There's the batch approach, and then there's also the real-time click data. So I think we should have our primary, it's just going to be this like raw data storage. It's just the ad capture. It's just the ad capture data store. So this is going to have a lot of data. This is the thing that's going to be bound by that big number. We're going to do our aggregation somewhere else, but that big number for the raw storage for 10 years of data, that's 365. So this thing has 365 terabytes of data, and it's getting when you pull data off of Kafka, it does reads at each shard does about 5 reads per second, but each read consists of 10,000 things. So it gives this like aggregated blob off of Kafka. You can't just write directly to the data store either. You actually need to have some task runners. Sweet, I do have that. So we have some task runners. That'll be one of the things that is reading off of this queue. You can just use Lambda or something is what I've personally seen at Amazon. So we have these, and they are just going to pull the messages off of Kafka, and they are going to write it over to the data store. And then we can talk about the schema over here. So I want to write down that we have 365 terabytes over 10 years is how much data we have in there. We want to have the ad ID, the click, the timestamp for the click, and then some metadata. It's just going to be like a blob. Okay, and the click will be like 1, 2, 3, 4. The timestamp, we'll use Unix epoch time, so it'll look something like that. And it'll be non batched up, so it'll be like it'll have a seconds granularity or milliseconds granularity, possibly even. And you get the click timestamp it can either come from the browser or it can come from this itself. Oh, I also want to have the UUID over here. So we have this UUID for the ad ID, and we're going to use that for deduping the clicks. And so we're also going to have the UUID of ad placement. It's like, so you have an ad ID, and it's going to get clicked thousands of times, hundreds of thousands, maybe millions of times. And each click event is going to have a different UUID. There's a bunch of different ways that you can do UUIDs. I won't go into it a whole lot. There's ways to ensure that they are unique, and there's ways that there's other things that just like bring down the probability of collisions to like 1 in 1 trillion, or 1 in the probability of it's something like the number of atoms in the galaxy is like the number of UUIDs you can generate, or something. It's something that I've seen. Oh, I haven't asked for questions yet. Are there any questions before I keep going?
Why not SQS instead of Kafka?
Okay, good question.
I mean, you talked about back pressure, right? But I think back pressure could be an issue even with Kafka.
Well, so Kafka is actually a durable data store. So you have a retention policy on Kafka. You set it to something like 7 days or something. I haven't really heard of Kafka having back pressure. In fact, with Kinesis, I think I've heard that Kinesis is actually implemented on top of DynamoDB. I've only really heard of back pressure being an issue with message queues. I haven't really heard of it with streams. Is that something that you have more information on than me?
No, I mean, I have seen SQS used in production in AWS also, and haven't seen such kind of back pressure issue. I think typically what I've seen is if there is a pub/sub kind of a scenario, that's where people really prefer Kafka. And of course, one of the reasons you gave is like we can have high throughput on it. But pub/sub is like the likeliest scenario when you say, okay, we'll use Kafka over SQS.
Okay. Wait. What was that last part? Can you repeat that? Sorry.
Yeah. Pub/sub scenario is where I've heard like that's probably one of the key elements of saying why you use Kafka over SQS or any other point-to-point kind of a communication
Okay,
method.
I think you can actually do pub sub on a message broker as well. I've heard it's with SQS. I think you can set up something with SNS. That's a common pattern is you do SQS, then you have SNS off the
Correct.
end of it, and then
Right.
you have a pub sub there. So you can actually
Right.
do that on SQS as well. But Kafka in Kinesis, yes, that's like a primary value add is pub sub. Another way that they vary is in how fault tolerance is handled when you have to do retries. So in message brokers, you actually in message queues like SQS, it's the broker itself that stores whether or not a message has been handled. While with streams, this thing will store its offset, and so this one actually stores whether or not a message has been. This is the thing that keeps track of that. Back pressure though, I don't think Kafka gets back pressure. I'm actually going to write that down as a thing to follow up on. Can streams get back pressure? I think this has come up before, and I actually just want to look into it afterwards, and I'll follow up on that. But yeah, I've not really heard of streams getting back pressure. I'll make sure to I'll follow up on that afterwards. But that's my primary concern with why I prefer a stream over a queue here is I haven't really heard of Kafka getting back pressure.
I mean, I can also do a little bit analysis on if SQS does have a back pressure issue in AWS.
Yeah.
Because they're also scaled to millions of events.
Yeah, it's so in general, when I have a higher TPS, I that's why I usually go with streams is like, hey, the TPS looks high here and I'm worried about getting dropped messages. And so that's why I prefer streams.
Yeah, because another thing is that SQS doesn't support your ordering, but I think and that could be one advantage for Kafka that your partitions could be ordered, right? But in this particular scenario, I don't think ordering really matters.
I'm not sure if Kafka can. I've heard with brokers you don't really want to use it for total order broadcasting. You don't want to typically use a broker for that. Good call out though is with ordering within brokers is that's another important consideration sometimes. I think SQS can ensure ordering. SQS might be able to
the problem is that if you do that, I mean basically you're talking about FIFO queue, right? In SQS, in that case, the throughput really reduces. I think if you use normal SQS, then your throughput is, I think, 10x faster than actually if you go down from normal SQS to a FIFO SQS. So that's why it's not preferred.
Yeah, total order broadcasting does definitely add latency. That's a commonly known thing. Is serializability or linearizability it's hard to achieve in a low latency manner.
Yep.
Well, all right, let's move on. Thanks a ton. That's a great question. I know this has come up before. I want to get to the bottom of it this time though. Thank you. Okay, and I see in the chat somebody has confirmed that with Kafka consumers are stateful and keep track of message offset. Yeah, we've covered that. Thanks a ton for confirming. And the other part was, do we need UUID of add to avoid double charging? Well, so the reason why I like the UUID is that then you can dedupe it. And so then we just have over here is that what I would do is I would add the UUID of the event, and it'll be some kind of wild long thing. Actually, I think it's like hexadecimal. And then you'll see like that it's some kind of really absurd long thing. For UUIDs, there's alternative approaches to ensuring uniqueness, but I like UUIDs for ensuring uniqueness because it makes it idempotent, and it's a lot easier to handle idempotent stuff for deduping. I think there's possibly alternative approaches to ensuring that we don't do a double charge, but this is my own personal preferred manner of approaching ensuring deduping. It's there's actually been long conversations in our Discord channel before about exactly once semantics and achieving it. Next week, I'd actually like to do another thing that specifically covers one of the bigger topics that's led to longer chats about exactly once semantics. It's on emails. But this is my preferred approach to handling deduping for avoiding double charges. Yeah. All right. Any other questions before we move on? All right, let's keep going. Okay, so we have our raw data storage. I haven't picked a technology for this yet either. So this can be, and I haven't picked how to avoid hot partitioning or anything like that. But for technology, it's either going to be Cassandra, or you could use time series database, possibly. I know with metric service, time series DB is a very popular way to go about that. Maybe it would make sense here as well. In the end, we're going to have, we're going to also have another database later on where we store aggregated things. And so we're going to be doing querying over time series, and then it'll pull it over to here. And when you're querying over the time, okay, I guess we don't need any kind of fancy index. I think either a B tree or an LSM tree will probably work fine. But how do you want to partition this? Well, there's 3 things that we might partition, do for a partitioning key or sort key. It's really, you want data locality when you're doing the aggregations, so that it really helps with avoiding doing a scatter gather thing. So it kind of helps to think about how we're going to be querying this data, is that we want to, so for the aggregation queries for a given ad ID, how many clicks within given time range. And so you want all the data to be local for a given ad ID. And so I think we would like to have partitioning over the ad ID, but then we're going to have a hot partition issue. So for example, if you have one ad that's particularly hot, like if it's a Coca-Cola running ads versus some new hot startup, or not necessarily a hot startup, but something that's only has a marketing budget of a couple $100 versus Coca-Cola, which has a marketing budget of $1 million. Coca-Cola is going to be running a whole lot more ads than the little startup. So that will lead to a hot partition. So you might want to go ahead and give up the data locality to avoid the hot partitioning on the writes. This is a tricky trade-off, because we also do have the stream in front of it. And so having a higher latency on the writes is not really as much of an issue over here. So I think it's okay. I think you would want to just go ahead and do scatter gather. And we would maybe just do Cassandra. I'm going to pick Cassandra, and then Cassandra, and we will do for the partitioning key, we'll do the UUID, and we'll just assume, so we're going to do something kind of like consistent hashing. And we're just going to assume that the UUID results in consistent hashing. If not, we can there's some way to achieve it. So we're doing consistent hashing. So we're giving up data locality for the ad ID, just because I think the hot partition issue might be pretty severe. And then within each thing, maybe sort by, so the sorting key will do, sort key is the timestamp. Okay, we got a question in the chat. The response of click capture service, which is the redirect event, is that only given once the write is complete? I assume not. If so, where is the redirect URL fetched from? So you are going to give the redirect URL here in the response. It's the redirect event with URL where you want them to redirect to is usually how you do that. So the redirect URL is given in the response. And then that's a good call. Is do you want to only give the response after the write is successful? So for example, what if so this is Kafka, or it's a stream, you're like not really supposed to design for outages of your stream. It's kind of like designing for outages of AWS itself or something. Some people do design for that, or an outage of GCP, maybe not as likely to design for that, but it's Kafka. It's supposed to be very extraordinarily high availability, and so you don't really design for it. And so I think you should just go ahead and assume that it's always going to be up, and you're always going to get really fast responses from it. And so you do only give the redirect event after doing a successful write to Kafka. You could do an async thing where you just go ahead and give the redirect URL and then asynchronously do the write to Kafka. I think either approach is fine. It's a matter of, you know, if you do the redirect without ensuring that's written to Kafka, that means that you could potentially have some dropped writes where you're giving you're kind of like giving off some like free revenue, like where you might give the redirect, but you don't properly capture it if you do it async. So I think what most people are probably going to do is write to Kafka and then give the redirects. That way they don't give any like free clicks to people. Yeah, good question though. I'd assume this is how they put it.
The question more so also is that where are we getting the redirect URL from? Is there a cache somewhere like for this particular ad ID?
Right.
What is the URL? Yeah.
Good question. Yeah. Okay. So that was not the focus of this. That was also something that was missed in Alex Shu's books. Is he also didn't go into that, but I assume that there's some kind of data store somewhere where you have a mapping of ad ID to URL for ad. So you have your HTTPS / some website.com. You have your ad idea of that. And so you're going to have something where the analyst is managing the ad somewhere, and then they are going to do some stuff over there. And then the ad placement service is going to pull data from here for placing the ads. And then, okay, where does the URL come from? Okay, so that is also going to come from here. So that would be, this is going to need to fetch that URL when they click the ad. Yeah, I mean, I guess you could even have the URL in the ad itself, and then all you're capturing is that a UUID was clicked, and then it would just be in the browser. And so you don't even need to have the URL retrieved from that. It will just be a redirect event on the client side is another alternative approach. And then clients could even pull the URL out of an ad without even clicking it if they're savvy. And I mean, that's an interesting scenario. I think you would generally design for it, assuming that they're not going to do stuff like that, because how many people are programmers that know how to do that? But you could also manage the URL being handed directly over here in that path instead of over here in the 304 redirect. I guess you could then, in that scenario where it's handled within the browser itself, you would be able to convert it directly to a 200 success. And maybe you don't even have to wait for the response. So there's a couple of different ways to approach that. I think you would probably want to prefer the URL to just be in there, and you try and get it. You would probably just be like, hey, they're going to click this. And then you go ahead and 200 success back, go to the URL. And then you don't even have to, then it's even lower latency here because you can kill off that operation over here, and you don't have to do another call off of your click capture service. And you could keep this in Redis. You can do either Redis or DynamoDB. Redis would be, of course, a little bit faster. If you're going to have it in the click capture service, maybe that would be a little bit more of a encouragement to be using Redis over here for just cutting down on that latency. But again, Redis is expensive. And then if you're just going to go ahead and have it on the ad placement side, which is on the page load, I feel like you can probably just get away with DynamoDB, possibly even over here. And so I think I'd prefer to have the URL just with the ad placement itself. And then this thing's just like telling you, hey, it's gotten clicked. I don't know how they actually do it, but there's a couple of approaches there, and that's my best guess. Yeah. I
think I agree with what you just said, right? Because typically, at least from my past experience, what happens is there is some kind of a JavaScript which is deployed on the browser, which act as a sidecar pattern and just drops an event into your click capture service rather than waiting on click capture service to actually send you the redirect URL.
Yeah. Okay. Yeah, I was thinking I don't really want to have, because so what if the storage is out too? What if the database is down? So Kafka, you can kind of count on that being up all the time. But what if the storage itself is down when when the click capture service is capturing the click. So
Right,
this,
but
yeah, so I definitely agree with you. You
yeah,
that even helps with availability. I agree with that. So it's just going to be a 200 success instead of a 3.0x redirect.
makes sense.
Cool. Yeah, and then somebody in the chat also was thinking the same way, where the redirect is in the initial request, which I'd assume they're meaning this one over here. Yeah, cool. All right, great question there. Yeah, I like to deep dive these things like this that aren't in the other material. I like it when we have our own coverage on fresh stuff that nobody else has really thought of a whole lot. Very nice.
Can I ask one quick question to you?
Yeah, totally.
And this popped up because you were discussing the whole schema and the partitioning thing on the data store. So I'm looking more at Kafka side. So the example that you picked up, right? Coca-Cola versus some newbie who does not have that big of a budget. One of the problems that I can feel that can happen with Kafka is if we just take all the events and just push it to Kafka, is let's say Coca-Cola has 100 million ads happening every 1 minute or something, right? And then there's a newbie who has very few ads being clicked. What can happen is there could be a noisy neighbor problem.
There could be a what problem?
A noisy neighbor problem.
Oh, interesting. What are
So,
the, okay, go on. Feel free to elaborate.
Yeah. So basically what can happen is, let's say there are 1 million users who see Coca-Cola ad and they just keep clicking on it. And those events will fly into Kafka. And then there is a small company who's also advertising. So they will have very few clicks. But those clicks will always, they might actually just sit behind those 1 million clicks of Coca-Cola, which is sitting in the Kafka. What that would mean is the Coca-Cola clicks will take their sweet time to get processed and stored in the data store. And those other clicks from the small company, for the small company that was happening, they will sit in the queue behind those Coca-Cola clicks. So even though they happened somewhere, let's say in middle of those 1 million Coca-Cola clicks, they will be sitting behind in the Kafka, and then they might actually be delayed in getting processed. You see what I'm saying?
Yeah, yeah. Okay, so we do actually have a few minutes for getting from end to end. I've definitely heard of similar issues with streams where particularly for processing jobs or something, if you have these big expensive processing jobs, and some people might have way bigger processing jobs than others, then when this really big massive processing job gets slapped on the queue or on your queue, then all the smaller ones suddenly see this big latency spike, and then it's like, well, what are we going to do about that? This guy's getting impacted by these big neighbors on the queue. Somebody once brought up I think it was like shuffle sort. You do some kind of shuffle trick with the things on the queue to handle for the what was it, the processing jobs thing. Somebody in the chat said eventual consistency is okay, so it doesn't matter when those clicks get processed. I'm kind of leaning on that a little bit here, but that is a good call out, is that you might have a noisy neighbor problem. I'm going to capture that here in the chat. And so then we can have it as a further topic to explore at the end. I'm not as familiar with the noisy neighbor problem, but I do know that since we have eventual consistency, maybe we're okay with having a little bit of extra latency on the Kafka queue.
Yep, makes sense. Yeah.
Okay, great call out though. Thank you. Okay. Any other questions before we keep going? Okay, we'll keep going then. So we got the ad capture data store, and we got that. I think I'm just going to do a sort cube timestamp. So that means that it's going to kind of be, I think if you use the timestamp in the partitioning itself, it would be a bigger issue. But I think since we have a sorting by timestamp, it might actually make more sense for time series DB. I'm not totally clear on when it makes the most sense to use time series. I think the greatest value add of using a time series might be the easier way to write a query. Might be why. That's also actually the benefit of a graph DB, is that it's easier to do the recursive calls when you're doing a traversal in a graph DB. So perhaps the main case for time series DB is that it's easier to write the queries. I think if you're just doing time range queries though, and you just have the greater than specific timestamp less than another timestamp, it's not really that hard to write it. I think there's a white paper somewhere out there on InfluxDB that might be a good paper to read. So that might be a good thing to return to offline. Uh-huh.
I think I'm a little split on the partitioning key being a UUID, because if UUID is specific to every single click, then it will always be a unique. I mean, we are saying that it's a consistent hashing kind of a thing, that we're just randomly throwing these events into the database. There is no partitioning schema per se, if you use UUID as partitioning key, right?
Well, so the partitioning key just determines the partition that it's going to land on. So it's that means that you're going to have a balanced load in terms of writes against every partition. So that means that you're not going to have good data locality, but it will ensure that there's a even load. But yeah, it means you're going to get some scatter gathers, which is not super ideal. I saw in Alex Shu's material for this chapter that he actually talked about MapReduce for processing some of the clicks, and that actually will work fine with scatter gather. You just kind of like aggregate them up for each ad and each of its shards where the ad occurs, and then you do a reduce where you reduce across all the different shards. If you're using Cassandra, that actually will have really nice integration with MapReduce. And that's one of the reasons why Cassandra might actually make a bit of sense here. Well, so if you're doing the partition key of UUID, that's where Cassandra might make a lot of sense. If you're not going to be doing partitioning by UUID and you just do it by ad ID, that might move the needle towards a time series DB or some kind of alternative thing where you don't. If you're not doing MapReduce, it might make more sense to switch over to the time series DB and maybe partition by that. I don't know how partitioning works on time series DBs either. So that's another issue there.
I think the point I was trying to make is that if you use the partition key of UUID, right, then the sort key doesn't really make sense.
No, it's here I'll draw a little diagram. So you have a DB and it's sharded, so you have a whole bunch of nodes. You have multiple nodes. You have node A, B, and C. And so the partition key just determines which of these three nodes it's going to find, where it's going to fall on. And then the sort key is how it's actually ordered within the partition itself. And so when you're doing the aggregations, each node is going to have, you'll have some at 1, 3, 7, 0.
I see. Yeah. No, thanks. I think that makes sense.
Yeah,
so effectively what you're saying is events will be distributed across different partitions, even if it's on the same timestamp.
Yeah, and then you're just doing a query with the timestamp, and so it's if you're doing a 1 minute range, it will just find all the ones that are right around here, and then these ones are filtered out because they're before the time range, and these ones are filtered because it's after the time range. So it's ordered by timestamp within it, and just take out your chunk right here, and that is moved over into MapReduce, which will be happening over here. Yeah,
makes sense. By the way, I don't know, probably you don't know this, but that whole MapReduce paradigm that you talked about, which probably Alex Shu's book has it. It's called Lambda architecture. So for real-time event processing, there are two ways that you can do it. One is where you have all this in-memory processing, and in parallel, you also do MapReduce, and that architecture is called Lambda architecture. Probably for folks to just look up later on.
As opposed to the Kappa architecture, which is where you're using Flink. I'm actually going to get into that. So we're also later going to have Flink for real-time data, and that'll be also doing a pull off of Kafka. Before I was actually confused about this. I thought Kafka was a stream itself. It's not. You actually have it on the end. And Jordan Has No Life, which is a YouTube channel, actually has a really good video on Flink. I didn't have a chance to watch it before this. I actually wish I did. I'm pretty sure that so you have to pull off of a stream. So it still is going to have to do a pull. And then I think you query this almost like a data store of its own. I'm going to write that in the open question is that Flink Jordan Has No Life has a good video on this. But yeah, that's the Kappa architecture as opposed to the Lambda one. I'm a little familiar with that. Great call out though. I appreciate it. And then I'll also say versus Kappa. Yeah, I was actually going to skim past this. I wasn't going to explicitly call out the Lambda versus Kappa thing. So thanks for raising that. Yeah. Any other questions from anybody before we move on? Okay, and we had one last thing in the chat, which is the reason not to use an add ID is a hot partition thing, right? Yes, it is. So I don't use add ID because it could result in a hot partition issue. The way that a hot partition issue manifests, the way that it shows up is that you get a higher latency against the hot partition. And so you're either going to get higher write latency. You can also get higher read latency against that one specific partition. So we'll say if we're aggregating by ad ID instead, we'd have all of our ads for Coca-Cola hitting the 1, and then we have small startup over here. And then if this one has another small startup B, can also be over here. So this one is small startup A. And then so this one's going to see latency as well from Coca-Cola's high latency. Could we do consistent hashing on ad ID? I haven't dove into how. I think you need to use another thing than just add. I think you need to use something in addition to ad ID in order to get consistent hashing, possibly. Or is consistent hashing where you do? There's that one trick where you do. It'd be like ad ID plus random number. And so you generate a random number between like 1 and 100, and that was the thing I saw in there was a section in DDIA where they went over the celebrity issue and ways for treating it, and you just take the celebrities and then you do this trick on them and you leave everyone else alone. And then this one would just be that the celebrities would then just be distributed evenly across that, and they get forced to do a scatter gather. That's actually a nice way to handle that here. I do actually like that. And then you get locality for the small ones. The small ones would get data locality, which is nice. And then I don't even know if you really need to do map reduce if you're going to do that. I don't know. It'd probably still help. And then you would still have scatter gather on the big ones like Coca-Cola, but those should be really small. It should be like, let's say 1% of the ads or something are going to be these big massive ones like Coca-Cola. That would actually be a nice way to handle that. Yeah. Maybe that's better. Yeah, you know what? I'm changing my mind. Let's do ad ID with celebrity approach.
I think one call out though that we can make on that is that it kind of like random number, right? It has to be so like the reason I'm speaking about this is we did something similar in our production scenario where we came up with a static number list, like let's say 0 to 10, right? And that's what we did, that we just did add underscore ID underscore randomly between 0 and 10. We'll just add a number 1, 2, 3, 4, whatever, yeah. Right? Okay. But that was a static number list. So let's say the pressure increases on the number of events that you have, and you want to go, and that 1 to 10 has to change to 1 to 20 now. So that is something that becomes an operational load that someone in the system has to know, okay, this is how we do it, especially for Coca-Cola, versus we do it for other small startups. So that becomes more of
it does add that does add complexity. Yes, that's going to add a lot of complexity. I like this approach. It's definitely going to add complexity, but it's going to be really nice for this is locality. It's definitely going to be really nice for operational load. It'll scale well. It definitely will add complexity though. I agree with you.
Yeah. Because now you have to have that logic somewhere sitting between Kinesis and your data store, the EC2 server or lambdas that you have, they have to hold that logic now.
Yeah, and as another call out for when you're scaling up and doing the rebalancing, I think consistent hashing does handle the rebalancing pretty well. It doesn't result in that was another thing that was called out in DDIA is like, what if you add an extra node, then you have to redistribute all the records to the celebrity possibly, right? Well, it's right. Consistent hashing does have a workaround for that. Good call out though. This is the random number of pinning things and add complexity. It's what handles the load the best though. Okay. Any other questions or call outs before we keep going? Okay, let's keep going. So we also want
Michael, just one small thing. Do we need to actually store that 10 years of data in the same data store? I mean, just out of curiosity, we can actually have it like for last 1 year of data, yes, it's in the data store, but there is probably some kind of a job that takes out other 9 years, the previous 9 years, and puts it in some kind of cold storage. Because you might not need 10 years all the time, right? Why have it?
You know what? I really need to do some coverage of change data capture. Is how I'm going to put it best is, so you're talking about something where it takes out a chunk from here, paste it into a different storage, not necessarily that one. We were going to say over here or something, it'll paste it over here and then it deletes it in the original. And then this can be something like S3 Glacier or something.
Got it.
Yeah, I mean, I've seen that. There's other approaches that I also like that. So I really do not like to ever do deletions of data. It's particularly bad to do deletions with Cassandra, which has uses tombstones for implementing that, which are high latency, and they're just you just generally don't want to do deletions on Cassandra. It's expensive. And I also don't like to do deletions in general, just because if you have complexity thrown into the mix of performing those deletions, there's more opportunity for programming issues where you write the code bad, it has a bug, and then you delete a bunch of data that you didn't intend to. What I really like to do is I like to have a thing that captures all of the data, and then you might have like a cache layer that's more hot. So for example, a lot of these aggregation queries are just going to be on the most recent data is really what we're going to be touching. So you could have it writing to 2 data stores, and then one of them has a time to live of like, let's say a month or even just a couple of, you only really need it for maybe a whole day, because you do the aggregations, you write it to this other one, and then so then this thing will have the time to live expire, and then you have the cold storage. We'll just keep it permanently, and then you're not doing deletions at all. And then this one's just going to use the time to live to let some expire. So there's a couple of different approaches that I know of for doing that. I've seen this at work in multiple different contexts at my previous company and my current one. Is yeah, when you have that much data, and the ones from 8 to 10 years ago is really not going to be touched a whole lot, probably not ever. But you just kind of want it there for auditing purposes or something. Then maybe you want to stick more of it into cold storage.
Right.
Great call out. I would actually like to touch that a little bit more in more videos. Maybe I'll cover that and I'll follow up with a short or something on change data capture. Great call out. All right. Any questions from anybody else before we keep going? Okay. So we are going to have a second data store where we're going to have the it's the aggregated clicks data store, where it's just going to have 1 minute granularity as opposed to this one, which has second or millisecond granularity. And so it's not going to show the individual clicks in the aggregated data store. And so we're going to have these task runners, or it's going to be map reduced possibly even, that'll pull from here, and then it's going to write over into this other one that has 1 minute granularity to it. And let's talk about the schema a little bit. And then I actually saw Alkshu did something a little bit different. He was able to just omit these 2 components completely, the task runner over here and this, and he had it going straight from Kafka into the aggregated data store. I'm not really sure if you're actually able to run aggregations directly against Kafka, but that's how he was doing it. Yeah, so that's the reason why I have Cassandra here, is I don't think you can actually run MapReduce directly against Kafka, or I haven't seen that personally. Let's dive into the schema here for a second first, though, is that we are going to similarly have the ad ID. We're going to have the timestamp, but it is rounded down to 1 minute granularities. And then so this one is a reactive, you can just use a Lambda function here, the AWS Lambda thing, and it's just set up with the trigger directly against this, while over here it's set up in more of a cron job style. You can do AWS Lambdas set up in more of a cron job style, where they're activated once a minute, and then they go and do a call. And so that's what you're doing over here. And then they do a call against this to do a query over for a given time range for each ad ID, how many clicks within a given 1 minute time range You of course will have an issue with straggler events. So maybe you would have it once a minute. You look at 2 minutes ago and aggregate over the 1 minute range from 3 to 2 minutes ago, or from 2 to 1 minute ago, just to make sure that all the stragglers managed to clear out of Kafka or something. Or you can just repeat it several times, and then the stragglers, you'll just have updated records over here for handling that. So there's a couple of different ways to do that. So the ad ID, the timestamp, and then you have the count, the click count. And that'll be something like 137 in 124 clicks in a single minute. And then you have your analyst, and that is going to, you need a backend service for them to talk to you. You can't call the DB directly from the browser. You shouldn't allow that. So then this is the analytics service. They're going to make a call to the analytics service. That one will make a call to this for them, get the data back, and then it returns that to the analyst. Okay, we can talk about how much data is stored over here a bit. That might be fun to calculate. We can also talk about real time, is that so this can actually be, so this is how Alex Xu was doing it, is that he literally had it just running right off the end of Kafka. And then he also did have a raw storage. So that way you could do reconciliation. You can do reconciliation every so often from here straight into the aggregated click store. And that could be how you handle straggler events. But yeah, he just had MapReduce running straight off Kafka. I've never seen that personally. I don't know how to, I don't know if you can actually do that. Okay, we got a question in the chat. Would there be a reason to not use Spark structured streaming, reading from Kafka? So that's another approach that I've heard of, is that instead you can just do Spark. There's this like Spark streaming solution as an alternative to Flink. So that would just be a similar solution. I didn't get all the way into how real-time data would work. But yeah, when you're talking about real-time data, you would use Flink or what is it, Spark streaming. So the analytics service could talk to this DB, or you could even have, if you're looking at, so this is if you're looking at more historical data, like how many clicks was I getting per day for the last 2 weeks, is you would talk to this one. But if you're looking at how many clicks have I gotten in the last 5 minutes, then you would have a query to, I think you would just call Flink directly instead. And then I only had this arrow over here was for the context of for managing a new ad campaign. Yeah. Okay, great call out though. That's another approach that you can go through, is Spark streaming, and that's like the second half of the streaming chapter in VBIA. Any other questions before I try to go into some machine count estimates?
So using so aggregation queries, right, for each ad underscore ID. If I'm thinking it correct, what you're saying is for every single ad that exists in our system, we're going to run the aggregation query against the ad capture data store. Is that correct?
For every ad ID, we're going to run an aggregation query against this store.
Yeah.
Yes.
Is that
well, so it's actually, you would do there's ways that you can do shoot, what's the name of it in SQL? It's like you can do a it's where you use the count function. So you're like doing it at the number, you count the number of times that this ad ID shows up for each shard. And then you reduce the map step is that for each shard of Cassandra, you're counting up the number of times that the ad ID appears within that minute time range. And then in the reduce step, you combine all the different shards outputs for that, and then you persist it over to here. I don't know if it would, I haven't actually written MapReduce myself. I haven't even gotten around to writing the paper, but it works something kind of like that, where if you were able to do SQL queries directly, you could use count. Sorry, were you going to say something?
Yeah, I was thinking of an alternative approach, if I may suggest. and we can brainstorm it. So what I was thinking is, instead of saying that we will go against every single ad ID and hit the ad capture data store, because that there could be cases that a lot of ad IDs have not been clicked upon to begin with in the browser. So we might be unnecessarily hitting the ad capture data store to look for clicks on them, right? So the other way could be that we can have bunch of lambdas, a bunch of threads as your aggregation queries service, and they will hit the ad capture data store, and they'll always look for anything which is marked as non-processed. So there could be a flag in the ad capture data store which says that, has this event been picked by the aggregation query service or not? So that way, only those events would be picked up by the aggregation query threads and processed and published to the aggregate clicks data store.
Has the job been processed or not? Has the event, the click event. So every single thing that we store in ad capture data store, let's say, is an event, right? A click event. Oh, and then you just add a flag for whether it's processed or not.
Correct. And then what we do is aggregation queries will go in, and let's say there is like, give me all the events that has happened in last 5 minutes or something, right? And then anything which is marked as not been picked up or not in processing state or whatever, then that thread can act. So it's like a locking mechanism on that event. That flag will is like a locking, that if no one has picked up, I'll pick up and process and push it to aggregate click data store.
Okay, well, so then you are updating the records. So Cassandra is best as a write-only data store. So if you're doing an approach of event sourcing, I'm actually personally a fan of event sourcing. You traditionally do not modify a record. You try to avoid modifying a record after you have written it. And so you would you don't really want to do an update, and I think that works better with LSM trees if you don't modify a record after you first wrote it. That might result in tombstone events where you have to invalidate the old record and then you write the new record or something. I think that's how that works with the LSM trees. I maybe have to double check. So I'd actually prefer to not have to do an updating of the record. That is a nice approach though. That is nice, particularly if you're doing DynamoDB or something like that with a B tree, where it's a lot more friendly about modifying your records. So if you're using B trees, I think that's definitely a really solid way to go. I think with Cassandra though, you maybe don't want to do that quite as much.
Makes sense. But like, then going back to the aggregation query current logic, right? Where we say for each ad underscore ID, because let's say it's Google, right? And Google has millions of ad IDs in their system. So if you were to run this for each 100 million ad underscore ID, that will be too many unnecessary queries being made against ad capture data store.
Yeah, so that you do not actually want to literally write a different query for every single ad ID. You don't want to do millions of queries. You would do I forget what the name of the operator is, but there's like in regular old SQL, you can use this count function, and with MapReduce, you can do something similar where you're not. Sorry, go on.
I was saying, are you referring to the group by?
Yeah, group by. It's something like group by.
Yeah, I think MapReduce would take care of it. You don't have to worry about the million different ad IDs. You just say group by ad ID, count, click.
Oh, I see. Yeah. So basically what we're saying is aggregation queries is actually a MapReduce system.
Yeah, it's well, so I mean, originally I was thinking of Lambda functions, and then maybe you can do something like group by in Cassandra's language. But MapReduce is probably the way to go here. And so you would probably want to be doing MapReduce instead. Okay, I see some questions in the chat. Are there any other questions while I'm reading through those? Okay, so what is the DB choice for aggregated click store? Yes, that is actually a really interesting choice. So I'm curious if you can get away with PostgreSQL as one option. So maybe PostgreSQL. Otherwise, DynamoDB I think would be really fun. I think because we're doing eventual consistency anyways. So PostgreSQL, if you can get away with it. Otherwise, DynamoDB. How many reads per second are we doing? So we have, for the analysts, I did do the math on that.
NTPS.
Yeah, 10 TPS. Yeah, so 10 TPS for the reads. And then it's for the writes, that's going to be hopefully like, oh, is it like millions per minute? You might be doing, because you're writing a record for every single ad ID, so you might actually be doing millions of write operations per minute, and then you divide that by 60, and so that would come out to about 60,000, because it's a record for every single one. Maybe there's a way to batch it up, but if it's millions and each one is getting clicks every second, well, I mean, you could also avoid doing a write for some of them that are just didn't get clicked in the last minute. So maybe only a few thousand of the ads actually got clicked in the second. And so then it would come down to like 3,000 TPS. But you might actually still be getting a lot of write operations. And so you might want to be able to shard it out. Yeah, I'd be interested in seeing some follow-up afterwards on this, but I'm leaning towards DynamoDB here, just for sharding, for primarily for sharding purposes. And then you would definitely want to shard it by the ad ID, even if you are getting a hot partition issue, just for data locality on the timestamp, because otherwise you're going to get a scatter gather, and it's the analytics service. This is external facing, and so you particularly care about those the data locality. So I would definitely pick a partitioning key of ad ID despite the hot partition issue.
Scatter gather might not be a problem, right? Because if your TPS is just 10 TPS, scatter gathering should be okay. I mean, that's very low TPS to be hitting across multiple partitions.
It's going to add latency. Scatter gather adds latency. It's the slowest partition, then determines your tail end latency. So it's not going to be a high load, but scatter gather means higher read latency, unfortunately.
Right, but I think but if you're okay, but I mean, if you're introducing high writes in lieu of having lower latency for reads, writes might introduce latency, right? Because if you're hitting hot partitioning, then you have to keep retrying the events, and that might introduce delays regardless.
You're not actually going to have, I don't think you would actually have as much of a hot partition on the right, since
I
it's
agree.
Pre-aggregated.
I agree.
The hot partition issue is a lot more muted. I mean, so I was also talking about how hopefully we're not going to be writing millions of records, as in, so we did say 2 million different ads, and I hope I'm not, if we're literally adding 2 million ad IDs every minute when this thing runs, then that would we want to avoid that. But then that would, if we're not going to write the empty records where the click count is 0, that would mean that the ones getting written are just the ones that get clicked every minute. So Coca-Cola is consistently going to be in there, but you know, all the small startups are not going to be written as much. I think I really think that the hot partition issue is going to be a lot more muted, though, because it still is, Coca-Cola still is only going to get 1 write per minute. So it's the hot partition issue is not, it's not nearly as pronounced as it would be over here. So you can probably get away with it. I think data locality is still going to remain pretty important. Yeah. Other questions? What's the DB choice? I'm feeling DynamoDB just for the sharding purposes. Yeah, it is an interesting choice. I thought that the aggregation will be done by the aggregation workers in front of the aggregated clicks data store. You are doing aggregation in front of the data store. Yes, you're doing the aggregation in front of it. So that's where it's being done. And then you might have it directly from Kafka, allegedly. Or you could have it against the raw one. Actually, had it coming straight from Kafka. I've just never had experience with that. So that's why I did the raw storage. Another thing +1, the problem could be updates, since now you have two riders, the same DB, one being the click capture service, and one being the aggregate service. Yeah. Well, so the aggregate service is not doing quite as much calls as this one's definitely going to be write heavy. This one's going to be doing fewer reads. It's going to be doing one big operation every minute. So it's fewer reads, but they're large and they're full table scans. And so that's where Cassandra and other LSM tree databases shine, is when you're doing the big full table scans once a minute on top of heavy writes. So we'll be running following query from Dynamo. Thank you for writing that. That's basically what I want. Yeah. Oh geez, come on now. I'm just gonna paste that over here. And we're gonna do that. And then we can have it in our diagram too. Thanks a ton for writing that. I appreciate it. Yep. Slack counts are from where at ID. Oh, I think you want to have group by. So our group by is going to be over.
Wait, sorry. This query is for the aggregated click data store, not the ad capture data store.
Oh.
So when the analytics, yeah.
Yes. Yeah.
Mm-hmm.
Okay, that makes sense. Yeah. So so you have, that is what you're going to run on this thing. Yes, you are correct. Yeah, that's what you want to do. So does DynamoDB offer ordering within partition? Yes, it does. In this case, we want it to be ordered for each ad ID as per timestamp. Yeah, so I did a thing about this in a previous video, or I might even done it in a short or something, is that you have your primary key, which is how it is on disk. Is the sort key is how you sort it within the disk itself. And then if you have secondary indexes, if you have any secondary indexes, like if you do, so here we sorted it by timestamp, but if you also wanted to do a second thing where it's like by one of the metadata things, that is actually going to be a B tree within the RAM. You store your secondary indexes are B trees on RAM. Okay, I want to hop off. I'm going to be at the Leak Code competition at 7:30. And I want to give you guys enough time to join that too. I'm going to post this recording. Any other questions can of course be in the Discord channel. I'll start a thread after this, and I'll of course upload this to the YouTube channel, of course. Any other?
Can I ask one last question?
Sure.
And this is more about the MapReduce. I don't know if anyone on the channel knows this, but we are saying that MapReduce job will run every 1 minute. Is that realistic, that a MapReduce can run every 1 minute?
That's why I was wondering if we maybe want to do Lambda functions or something instead. It's not going to be running over the entirety of Cassandra. We would want it to extract out a little section of each shard. And then MapReduce does actually have a really nice integration with Cassandra, because they're both part of Hadoop. I think Cassandra is actually on top of HDFS, and then MapReduce can run really well with HDFS stuff. But yeah, I am curious. I've known MapReduce functions to usually record. They're usually intended for stuff where you run it for like several hours or something.
Yeah.
So the choice of MapReduce now choose chapter was kind of interesting in that aspect.
Yeah, even I was actually wondering that MapReduce doesn't seem like a right choice in terms of technology for aggregation here.
Okay, another guy said something about Flink Spark streaming might be nice for the, so another approach could be, this one's aggregating it as you go, and then your query service just makes a call to Flink or Spark streaming instead of doing that. And then you just delete that, and then you have the add data store. That's also a nice one. So like once a minute, you're calling Flink to get the aggregations. And then you can do reconciliation every day or something from here over to here. And that would maybe be where you would want to have MapReduce, since that would maybe that is, yeah. I kind of like that approach.
Yeah, in fact, the latter approach is common in machine learning, where you have this raw zone for batch features, and then Flink or Spark Streaming is reading from your Kafka source directly and writing to an aggregated data store, which is like your feature store service. Yeah. So I think, yeah, what you have now seems also suitable, going from Flink to aggregated click data store directly.
And with. Okay, it's 7:26. I really want to get to this leak code competition because I make them almost every week since like January. Feel free to post more questions in the Discord channel. I'm gonna hop off and post this to the YouTube channel. Thanks for joining, everyone.
Thanks, Michael.